Well, think about this for a moment. If this thing is a protein factory, it's making all these proteins. What happens from the standpoint if you need a certain protein? Okay? One of the things that's so cool about how we're made is the feedback systems that are built into our body. Let's say for just a moment we're looking for a specific protein in our cell. We'll call that the final product that you see on the screen. In order for us to get that, what has to happen is it has to go through oftentimes multiple steps to get to that final product. So you have to have a gene that turns on that produces that very first box that you see over there. But if you notice that for each arrow that's on there, there's a special enzyme that's necessary to bring the reaction forward. If you don't have all the enzymes present, all the different parts, all of a sudden this reaction's not going to work. So you've got to have genes not only for the first SO type of thing there, but also for the enzymes. And each enzyme is very specific. It has a certain shape and a certain size to it. So all of a sudden, let's say that the cell says, here we go, we need to have this protein, all right? These proteins start building up, building up, building up, building up to the place where now it's helpful for the cell to have what it needs. But wait a second, what's going to keep that protein from becoming too much? Because it's just building up, building up, building up. Well, like I said, there's feedback mechanisms. What turns out to be the case is the final product that's actually being made, the protein, has a special shape to it that just happens to be able to bind with the very first enzyme, E1, so that it keeps the reaction from going forward. What we see is foreknowledge built into the system from the very beginning. That's pretty amazing. Now wait a second, we know that most biochemical pathways are more complex than this. Let's look at another one. Here's one that's branched. Here we have two potential products that are going to rise if you get started with the very first initial chemical SO right there. Let's say for a moment you need both P1 and P2. Both of them are a little bit low, so the genes click on, and all of a sudden it starts producing these different proteins. Well, let's say that P1 doesn't need to have that much more produced. So it needs to click off first before P2 does. Well, how is it going to do that? If we look at the mechanism we saw previously, where that structure of P1 would compete with that very first set of reactions at the very beginning, it would also shut down the reaction going to P2, wouldn't it? Shut the whole thing down. Well, the way God designed this thing is the actual mechanism will basically inhibit it right where it forks at it, right where the branch is. That its shape will be a competitor against the enzyme right in that spot. So now all of a sudden you can have P2 building up as much as you need it. Okay, so P2 finally gets to the point where it's going to be high enough for the cell, and that shape is going to inhibit that little arm of the branch. That's pretty cool, isn't it? But now we have another problem. We have both of these things competing at that point. Now there's going to be too much S2 building up, won't there? That's just going to keep going and going until there's a feedback mechanism. Well, look what God does. He puts also a feedback mechanism that will stop it at the very beginning. What we see is forge and planning at the chemical level. If any of you have ever been sick and you go to the doctor and the doctor takes blood from you and he basically gets back this biochemical panel that shows all the normal ranges of what normal is, do you think that's by accident that everything is kept within a normal range? There's these kind of systems going on constantly to keep things in balance. Strong evidence that God is the creator. Feedback systems are a precisely programmed demonstration of foreknowledge and deliberate, purposeful planning.